here, notice sometimes students have trouble deciding whether to use law of sines or cosines. So if you start off trying to use law of sines, you would have, I wouldn't write this down because it's not right, sine 98 over A equals, you'd have to have something like sine B over 12. Or maybe sine C over 15, but the problem with that is you would end up with two variables in the problem. So law of sines is just not going to work if you try to set it up. So if that's the case, then that should tell you that law of cosines is what you need to use in that case. And as I said, here we do have side, angle, side, which is also going to tell us that we use law of cosines. So side A is the side that we want to find. So we're going to have A squared equals, and then it doesn't matter which one is B and C. I could use either one. It doesn't matter which one here, but just for the sake of the letters, this is 12 is side B, and 15 is side C. So you have 12 squared plus 15 squared minus 2 times 12 times 15 cosine of 98. So, let's see, calculator up here. So, the good thing about this is it's really easy to type into the calculator. Or Desmos. I just like the calculator a little bit better for just typing stuff in like this. I like Desmos 1,000 times better if I'm trying to graph something. Okay, so I'm getting 419.102. And remember, that is not your answer, because we got A squared is equal to this. So then we would take the square root of this answer. And so we will get 20.472. And that seems to be a reasonable answer here. The sides are 12, 15, and 20. That seems reasonable in this case. You do want to check, like, what I find sometimes students do is they forget to take the square root, so they get answers like 419. It would be ridiculous to think that that side right there was 419 if the side is only 12 and 15. All right, so think back about how it fits in your triangle to make sure that it makes sense. Okay, questions? All right. Okay, so here's just an application problem. I love trig because it's so applicable. We do have to boil things down to make them a little bit easier than they would be in real life, mostly because we are still in high school and we can't quite handle all of the factors. But car A and car B leave the same point at the same time. Car A travels north on a straight road at 60 miles per hour. Car B travels 20 degrees south of east on a straight road at 45 miles per hour. After 2 hours, how far apart are the cars? So it's unlikely there's going to be a straight road that's straight for long enough for you to drive 2 full hours on, right? Much less 2 of these straight roads. But we're simplifying it a little bit more. So what I would do is I would let that point where they leave from, let that be the origin. And so you've got car A, and let's say car A is a criminal that's just robbed the bank, and they have taken off north at 60 miles per hour for 2 hours. So how long should that side of the triangle be? 120. Okay, and let's say that this criminal is making their getaway this way, but there is also an identical car that leaves this area at the same time, and they're going to travel 20 degrees south of east. So 20 degrees south of east is going to look like this. Of course, we have north, south, west, east. And so 20 degrees to the south of east is going to be, you'll have a 20-degree angle right here. And that car travels at a rate of 45 miles per hour for 2 hours. So how long should this length be here? 90. All right. So let's say that the helicopter is following this car. They thought this was the car that had the robbers in it, and so they've been chasing this car right here for 2 hours. Obviously, unsuccessfully. That's a long time. I probably should have made a shorter time frame here. But this car is not the robber. So now the helicopter is right here, and they have spotted the actual robber way up here. So if the helicopter is wanting to go from here to here, we know how far that would be. And the helicopter doesn't have to follow the roads, so it could go straight to this point, right? So this side right here is what we want to know. That's where our X is at. So I've got this triangle here. It is not a right triangle. But I do have two of the sides, and I don't have this angle right here, but I think I could find it. What can I do to find that angle? 90 plus 20, because we know north and east make a 90-degree angle, right? Plus we've got this 20-degree angle right here. So this whole angle right here is going to be 110. So that is our angle that we're going to use for our law of sines. So the side across from our angle goes right here. And then we're going to use our other two sides, 90 and 120. Doesn't matter which one goes where. So 90 squared plus 120 squared minus 2 times 90 times 120. And then cosine of the angle, which is 110. So, just like the last problem, we just have to type that into the calculator. And so we're going to get x squared equals 22,561.56363. And then we will square root both sides. And so we get 150.205. Oh, I didn't, did I? Had that there on my end. Let's fix that. Left out that 120, so really we should have there 2988.7.6351, which is going to give us 172.880. and that would be miles. In this case. So the helicopter can go a lot faster, but still probably going to take them like 30 minutes to catch up to the robber here, depending on how fast it can go. Possibly longer if it's a slow helicopter. I'm not sure how fast they go. Okay, questions? All right, so we're going to do one more type of problem, and then we will. I will let you guys do your assignment. So the second type of triangle that you can use law of cosines on is one where you have all of the sides and none of the angles. So in this particular case, we've got x, y, z. So x is the shortest side. Y is next. So I'll put it here. And then z, 22. So these are a little bit tougher to solve because you're going to have to do a little more work in the solving part. The calculator does most everything for you whenever you have that angle. We're just going to pick an angle to solve for first. It does not matter which one we choose. Grace, which one would you like to choose? Z. All right, so if we're looking for Z, we'll put 22 squared equals, let's see right there. And then we'll do 14 squared plus 19 squared minus 2 times 14 times 19 cosine of Z. Now, you could have used a different number there. That would have been fine. So we have to solve in this case for that Z right there. So this one is going to be where I actually sort of have to solve an equation. We can't just do the whole thing in the calculator. So 22 squared is going to give us 484. $14 squared is 196. 19 squared is 361 minus 2 times 14 times 19, 532 cosine Z. So, biggest mistake most students make is they go ahead and put all three of these numbers right here together. You cannot do that because this 532 is right beside of the Z, so it's going to have to stay together for right now because that has a cosine Z with it. So we can get rid of the 196 and the 361. We can put them together first and subtract them, or subtract them separately. In fact, what I usually do is I just usually go ahead and add them together before I write them down. But if we get rid of both of them here, we'll have 484 minus 196 minus 361. It's going to give us negative 73 equals negative 532 cosine Z. So at this point, you're trying to get the cosine by itself. You're going to divide by that negative 532. So we're going to get 0.13721 equals our cosine z. And then how do I undo cosine? Inverse cosine. So I'm going to do inverse cosine of that answer. And I'm going to get 82.113. Now, to really be precise, it is a good idea to store this. No, don't store it as your x. Store this as your z. Right there. Or you could use a different letter, A, B, C, whatever you want to call it. So that is one angle. But they asked us to find all of the angles. Right? So I could go back and do law of cosines again. So you could certainly go back and do law of cosines again and find x or y. However, I think law of sines is a little bit easier. So now that we know that this side right here is 80, or this angle right here is 82.113, we can use law of sines if we want. So we could say sine of 82.113 over 22 equals sine of x or y. It doesn't matter which one you want to use. I'm going to do x over 14. And so we can cross multiply 22 sine x equals 14 sine 82.113. Can divide by 22. And then, excuse me, we'll do that part in the calculator. I'm going to do sine of z since I stored it. Okay, so I've got sine x equals 0.6303 and so on. And then I will do inverse sine. And so x equals 39.076 degrees. So I've got z, I've got x, y is going to be our easiest one to find once we've done this. So, Noelle, what do we have to do to find y? We can, but there's an even easier way. Good. We can just do 180 and subtract that number we just got and our z, and then we'll have our answer there. So 180 minus this answer minus that z is going to give us, for our y, we will get 58.811. Questions? All right. Excuse me. So, now we're going to have another worksheet with law of cosines. And the great thing about law of cosines is there is no ambiguous text for law of cosines because you're either starting from side and side or you've got all three sides. So Let's do odds again here. I think that'll probably give us enough practice. If you work hard, you might